All right. Hello, everyone. Firstly, thank you to Peter for inviting me. This is a great privilege to be involved in the first Scotland JavaScript conference. Thanks, Peter. That's all right. So I thought I'd start by summarizing the talks that we've had so far today. So I think I can safely summarize Peter's keynote this morning with that, lol HTML menus. This was actually my talk before your talk this morning, so so I think we can safely say that JavaScript has changed quite a bit since 2004. From the days that we were adding just a little bit of the HTML scripting here and there, a bit of DOM scripting, and quite often copying the HTML menu code from other websites, and actually paying money for it as well. I remember that. Remember paying money for DHTML menus? Crazy. So 2012, and to summarize the other talks that we've had today, callbacks everywhere, real-time stuff, amazing, networking, and memory, and mobile. So the point here is that JavaScript application development has become extremely complicated. And for people like myself who maybe don't come from a software development background, I'm actually a psychologist by training, we really need processes and tools to help us manage this level of complexity in development work. And a couple of the tools that can help us are the things I'm going to talk about today. So firstly, Backbone. And really, I've only chosen to speak about Backbone because that's what I know. A lot of what I'm going to talk about today will actually relate to other JavaScript MVC libraries as well. So I've just picked Backbone because of my own experience. Now, Backbone uses, like all MVC libraries, uses separation of concerns to make a developer's life easier, essentially by separating business logic and business data from the view, from the UI. It allows us to simplify and break down our application. And test-driven development, in a way, has the same motivation. So test-driven development allows us to kind of break down our big, complex problem of building a web application into smaller, granular parts. And to look at those individual parts as a single problem and kind of fix that first and then move on to the next problem. And really, these two things go together very well. And the reason for that is that Backbone really consists of quite well decoupled units. They're not totally decoupled, but the references between different Backbone objects when you create your application are fairly minimal. And a lot of the communication that's done in Backbone would generally be done using events. There are also few external dependencies, so really you're talking about jQuery or Zepto in terms of the DOM manipulation, but other than that, it has its own underscore library, of course. But other than that, there's really very little dependencies outside. And then Backbone also uses declarative conventions quite a bit. So we have, for example, in Backbone models, you can declare default values on your model attributes. And in Backbone views, you can specify an events hash which will declare what events you want to respond to from your view. And these, because they're declared rather than written in boilerplate code, it means you can get away with writing fewer tests. So we're going to talk about TDD. The TDD cycle, I'm sure a lot of you are familiar with this. We start with a failing test. And we call this the red phase because when you run a test through Test Runner, a failing test will generally be shown in red. And the intention here is to explore the API of the object that we're going to write before we write it. So you're really kind of coming in from the outside and trying to understand how your code is actually going to be accessed by other parts of the system. We then make that test pass really as quickly as possible. And the intention here is not to produce your best ever code, but just to get it working so that it passes your test. Really then the next step is to kind of look back at that and see whether there are opportunities for refactoring. So by removing duplication or by possibly abstracting your code and extracting generic methods, for example. And then we repeat the cycle. So we write the next failing test, we make that pass again, And as you go around the cycle creating more tests and more code, you'll see more and more refactoring opportunities emerge. So the intention here is to produce kind of an emergent design for your code. So it comes out of writing, you start with your intention, and then if you do it in the right way and write the test in the right way, then you'll come up with a fairly, in theory, come up with an elegant solution to your problem that's emerged from your intentions. But test-driven development has been sort of criticized in the past by lacking context. So it doesn't really help us with questions like, where do we start? What bit of code do we start writing? And also, are we finished yet? So how do we know when the feature that we're working on, the piece of functionality that we want to provide, is actually complete? And so it's quite easy to go off on a bit of a yak-shaving adventure. You might go down a pathway and getting all excited about a bit of functionality that actually isn't needed right now and may not actually ever be needed. So in 2005, Dan North devised behavior-driven development. And this is really, the intention here was to reframe the practices of acceptance testing and unit testing as kind of a development practice. And it takes inspiration from various agile development practices other than that. There's a big focus on business value in behavior-driven development. And by this it means every bit of functionality that you write must have some kind of value to the business, otherwise what's the point in doing it? There's also a big focus on user goals. Likewise, there's no point writing a piece of functionality that doesn't have some value to a user of some kind. And finally, and probably the most important thing that BDD stresses, is the value of communication. And the idea here is that BDD attempts to create a shared language and a shared vocabulary for stakeholders of the project to use with each other. So, and the stakeholders here can be developers, QA, product owners, and of course users. The idea being that if you're sharing the same language throughout your project, there's less opportunity for misunderstanding and for creating completely the wrong thing. So this allows us to go about a project in an outside-in manner as developers. So starting from the motivations of our users and our stakeholders, we can describe those in a fairly kind of high-level way. And then we can go a little bit more detailed and describe individual scenarios of interaction with the system that will actually result in those user goals being satisfied. And finally, getting even more detailed, we can look at the behavioral aspects of the system, so the interactions themselves between the user and the system, but also between individual parts of the system, so between our different units. And these are all described, the scenarios and the behavioral interactions can both be described as testable behavior examples. So like test-driven development, BDD has a development cycle associated with it. We have the unit, the unit cycle as in TDD, but framing that, we also have a cycle of acceptance testing. So the process here is much the same, except that we start with a failing acceptance test. And the idea here is that we're testing an entire scenario from start to end. And of course, when you write that test and you run it, the first thing that happens, it should fail on the very first step, because if you haven't written any code yet, it won't even be able to access a web page. And at that point, you can then drop down into the unit level and start writing unit tests. Now, the acceptance test will give you a clue, sometimes a very big clue, about exactly what unit you need to start work on and what behavior you actually need to specify in your system. You then go around the unit cycle and keep going. So every time you get to green in a unit cycle, you can rerun your acceptance tests, and they will usually continue to fail, but the reason why they fail will change as you progress through that scenario. And eventually, you'll get to the point where your acceptance test also passes. You then, of course, have another refactoring step. So you might decide, having completed an entire scenario, that your implementation is actually complete shambles, and you want to rip out your entire object structure and start again. And having an acceptance test gives you that opportunity, because you can now delve back into your unit level and start refactoring, knowing that you're going to get back to a point where you're going to have a green exceptions test. So I'm going to talk about some of the tools that are available in JavaScript, both for unit tests and for acceptance tests. First of all, though, the bad news. Automated acceptance testing is a massive pain in the arse, and it has been ever since, really, people started trying to do it in browsers. And I think, really, it's a bit unfair to say that one in particular is worse than the other, because the main problem is that they're driving the browser. And anything that attempts to drive the browser really that's quite a difficult problem, it turns out. In particular, some of the pains that you get from acceptance testing are that they run slowly, particularly if you're driving a real browser. You can quite quickly end up with a long-running suite of acceptance tests. And if you get in that situation with a team, your team will tend to avoid running those tests at all costs. They can also be non-deterministic. Now this means, if you're not familiar with the terminology, this just means if running the same test in apparently the same circumstances may not always result in the same outcome. And so when this happens, it can be difficult to debug that situation to actually work out what's going on. Your normal approach to debugging a problem in a web browser may not be available. And there's also a potential problem with incomplete browser features. Now, some acceptance test frameworks allow you to test in a browser, and others allow you to test in a headless browser, which is essentially a browser without a rendering component. Now, those headless browsers can either be quite accurate simulations, or they sometimes can miss browser features, particularly with more recent HTML5 APIs, for example. You might not have local storage or geolocation features, stuff like that. So I think it helps to bear this bit of advice in mind. This is from Brandon Keepers, who works with GitHub. And what he's trying to say here really is that because functional tests are a bit of a pain in the ass, they run slowly, they still have value, and the value is really in keeping it to your core features of your application, your core use cases, and probably to avoid trying to test things like edge cases and exceptional circumstances like error scenarios and secondary functionality, for example. But the question is, we're all JavaScript developers. Some of us are JavaScript developers only and may not be familiar with other languages. Now, there are plenty of acceptance test frameworks in other languages. So we have Selenium, which largely allows you to write tests in Java. Cucumber is popular in the Ruby community, for example. But if you're writing a heavy JavaScript web app for the front end, it really makes sense to write your acceptance tests in JavaScript as well, because you can directly access the DOM and global elements on the target page that you're interested in testing. So I'm going to talk about a couple of options, a couple of tools that are available. First of all, there's Cucumber.js. I believe Julian is here today. Hi there. Julian is the author of Cucumber.js, so if you've got any questions about that, you should probably ask him rather than me. But I'm going to show you can use Cucumber.js with a headless web browser called Zombie, which is available as an NPM module. The other option is Casper JS, and this is a scripting utility that's based on PhantomJS. So PhantomJS is another headless web browser, but it uses the WebKit rendering engine internally. And those two tools have slightly different approaches in how you go about testing. So we'll compare examples from both. So our example, we're going to have a very simple example of Snippetron, which is a revolutionary code snippet manager. And this is on GitHub, and I'll show you the link later on. But don't get too excited, because I've only actually implemented one scenario, so it doesn't really do very much at the moment. But feel free to fork it and turn it into your $1 million web app if you want. So we're going to start in BDD tradition. We start with a user story. So again, I think Leo showed a user story before. If you're starting from, if you come from a kind of agile development background, this will be totally familiar. So as an efficient developer, I would like to save a snippet, so that I can retrieve it later. So this kind of defines our overall user goal and also the behavior that they want to interact with the system. Now, we can describe one or more scenarios that will satisfy this user story. In fact, you'll probably need quite a few scenarios to fully describe a feature. Now, a BDD scenario will have three parts to it. So we start with the context. So given I have no snippets yet, for example. The second part is then a condition, so, or an event that occurs to your system. So when I fill out and submit the snippet form, so this event comes from the user. And then the final part is actually the piece of behavior of the system that you actually want to measure and observe. So in this case, I should see a message saying my save was successful. So again, BDD is about communication. So the idea of this is really to start from the point of view of describing and discussing with your team in English what you're actually going to do. And as part of that discussion, you might prepare some wireframes. You might even mock this up and do some user studies before you actually write any code. So here's our form. This is a very early prototype. So we say we've just got a form with the title for the snippet and the contents, and then a submit button. And of course, it's a backbone app, so all this is going to happen on a single page. So when we hit the submit button, we're just going to get our confirmation messages like that. I told you it was going to be simple. So first of all, we'll look at Casper. Sorry, Julien. And as I said, Casper is a scripting and navigation utility. It's really just a way of driving PhantomJS in a kind of it provides a slightly simplified API and some extra tools on top of PhantomJS. So for example, we can make assertions using Casper. So this helps us to actually make assertions against the target page DOM, for example. So we can, on a very simple level, we can assert against the text of an element. Against the page title, we can check URLs. We can assert that the HTTP status is as we expect, and so on. And we can even check whether images have downloaded. And it also provides a number of features for driving the browser. So we can navigate back and forth, we can emulate click events, we can fill out a form, and we can inspect global JavaScript objects and their values. Also very handy are the wait methods. So if you've got, you're running a real web application, so things may take time, like network connections, AJAX requests, and so on. So you can actually use wait conditioners to wait for particular conditions on your page, and we're going to be using one of those in a minute. So as an example, what a Casper test might look like, I'll just jump through these. So we can put in comments, that's very handy. But really it all starts with the start method. So start really, it just loads the URL into the Phantom browser, and then you provide a callback to specify some actions that you would like to take when that load is completed. And in this case, we're going to fill out a form. So you can provide the values for the form fields, and then we can submit that form by using a click event. The next step is to then use our wait method. And so we use wait until visible here. So we're going to wait until our element of class message is visible, and then again in the callback for that, we can assert that there's our confirmation text is on the page. We can also provide a timeout callback. So if that wait, if that condition in that wait doesn't occur after a set period of time, we can call something else. And in this case, we're going to debug the output just to see what really did happen. And also, you can explicitly fail the test. So if it didn't happen after 3 seconds, we're pretty sure that we want to fail that test and find out why it's so slow, even if it did come back. And then the final thing you need to do with the Casper test is actually run it at the end. Anyone who's worked with promises will know that this is a promise-based structure. So at the end, you need to say, yeah, actually run this, and then again, a callback says that the test suite is completed. So this is what test output looks like, and the big red bar gives us a clue that it's not working. And the error here is it cannot dispatch an event on non-existent selector, input type equals submit. So it's trying to hit the submit button, but it's not there. And the reason it's not there is we haven't written any code yet, which is great. So that's exactly what we expect. So we're going to come on to looking at the next step here, but first of all, I'm going to do the same thing in Cucumber. Now, the reason I'm doing both is because I haven't really decided which is better yet. So we'll look at Cucumber, and I'll let you decide for yourself. So Cucumber, if anyone who's worked with Cucumber in the Ruby community, or I think there are ports available in a number of different languages, Cucumber uses a plain English style language called Gherkin to specify features. This basically means that you can write, at the top of a feature file, you might have a feature description, and this is really just a user story, like we came up with before. This feature doesn't actually get parsed by Cucumber, it's really just there for humanized to give a setting for the scenarios. So as I said, a feature might be satisfied by a number of scenarios. So here's one scenario. And this is the part where the Cucumber actually starts to parse. So again, this is specified in standard BDD structure. So we have a given condition. So given I am on the home page, when I enter my snippet into the snippet title field, and likewise the snippet content field, and I click on the create snippet button, then I should see a message with my snippet saved. So that kind of reads nicely as in English, and you can discuss this with your non-technical team members. But the point is that Cucumber can parse this into real JavaScript steps to run in your acceptance test framework. So as an example here, we have the given step, given I am on the home page, that just translates to running a visit command on the Zombie headless browser. And for each step, we have a callback function that's passed in. And we have to call this callback at some stage to basically tell Cucumber that step is finished. And move on to the next one. The second one here, so this is the when step. So when I enter in the field, you can see that those values, those regular expression values, are provided as variables in the function, so we can then call those. So this makes it a generic step, which means you can reuse it wherever there's an input field across your application. So when you're writing these steps, you're writing them in a generic way and building up a toolkit as you go along. So in this step, we're just simply filling in that field with the values provided, and again, calling the callback afterwards. Finally, a then condition might look something like this. So I should see a message with and again, we're just testing that the text value of the message element actually contains that value. And if it does, we can call the callback, and if it doesn't, then we can explicitly fail the test with an error. So again, this is what a Cucumber test run output looks like. And again, the error is fairly similar. So this time we have no input matching snippet title. So it's trying to enter the value into the snippet title field, and it can't find it because it doesn't exist. So that's a lot of work up front. You haven't written any code yet, right? But it's time to write even more tests before you even start writing code. So at this point, we can move down into the unit cycle and start thinking about what unit tests we might write. Now, the question really is, what unit do we work on? And a failing acceptance test can give us with a big clue about this. Usually it's fairly explicit and obvious. Sometimes it's not quite so obvious, but in this case it is. So Casper JS is telling us that it can't click the submit button, and Cucumber.js is telling us that there's no input matching snippet title. So it's obvious that what we need to do is actually render this form out to the page so that these operations can go through successfully. So at this point, it's probably worth doing a little bit of planning around how you're going to construct your JavaScript application. So in this case, I'm going to create a backbone view called form. And that's going to be responsible for rendering the form, but it's also going to have a submit handler. So when the user hits the submit button, the form view handles that and then creates a model called snippet. And also going to ask it to save it at the same time. That snippet model is then responsible for making the actual post request to the server that's going to actually save it into the database on the server. And the server will respond back saying, that's all done successfully, And the responsibility then is handed back to the view, which has a handler for the success and shows our confirmation message. So fairly simple. But there's two units here, so we've got the model and the form. So, unit testing in JavaScript. Now, it's much more mature, the tools are much more mature, and there are a lot more of them. So, there are just heaps. I'm not going to talk about all of them. Many of you will be familiar with QUnit and probably written QUnit tests. First, certainly this was my first exposure to TDD of any kind within QUnit. But this QUnit uses a kind of traditional TDD syntax, so a kind of XUnit syntax. And in the last year or two, Jasmine BDD has come to the fore, which uses a behavioral-driven development syntax. And there are other ones, for example, Mocha, which allows you to do Node.js and browser testing using either BDD or TDD styles, various Node.js test frameworks, and loads of others, that are, some of which are getting very old and unmaintained now. But I'm going to talk about BusterJS. And the reason for that is because it's kind of a new kid on the block, but also it's got some neat features to it which are pretty handy in kind of modern web development. Probably the main one of those is it allows you to do simultaneous cross-browser testing of your unit tests. So what you can do is you can open up a bunch of browsers, point them at a URL, which is a Buster server, and then when you run your tests, Buster will request that all of those browsers run the test simultaneously. So you get, in your terminal window, you'll actually get results for every single browser that you've signed up. So, and this can include mobile devices as well as traditional browsers. So you're doing very early cross-browser testing in an automated way, which is pretty neat in terms of finding bugs, particularly on Android. It also provides both TDD and BDD syntax style, so if you've got a preference for one or the other, that's fine. But most importantly, and really the thing that's transformed unit testing for me is using test tools extensively, so using spies, stubs, and mocks. And if you haven't done this yet in your test, you're not using these yet, then I would encourage you to spend some time learning how to do it, because it's really quite transformational. And the purposes of using test doubles or stand-ins is to isolate the subject of your test and to keep it away from nasties, as I'll come to in a minute. And really the purpose of that is to ensure determinism. So you want your test to run in exactly the same way each time and always to always produce the same result. And you do that by protecting it from these flow-dependent external dependencies, such as the network, for example. And you can also have inconsistent or incomplete third-party code that you're relying on, that you maybe for your test you want to remove and emulate. So I think the biggest one of these is actually network connection. And when you're running your unit suite, you should really, you shouldn't really have to have a running application server to run your unit suite. So Sinon provides a bunch of tools for doing this. You can create spy methods. So a spy method is simply a normal method with additional properties that records how it was called and with what arguments. And this is great for event-driven code because you can inject a spy as a callback into your code under test, run that code as you normally would from an external point of view, and then later on during your test you can inspect it and ask and make assertions against how that method was actually called. You can stub responses, so you can say you want a particular method on a particular object to return in a particular way, so you can emulate error responses. You can use different scenarios, and you can just directly manipulate that rather than struggling with and trying to write your own. And server interactions we've already mentioned. And finally, if you've got a lot of animations, for example, in your web application, or if you've got other time-dependent stuff, you can actually manipulate, well, time, not space, maybe. And it just does this by, it wraps the set timeout and set interval methods and allows you to contract that time. So if you have a 10-second animation running on your web interface and you want to check the state of your application at the end of that, you can just jump forward that 10-second period directly and so it doesn't slow down your test suite. So, we're going to have a look at a very quick example of writing a spec, as they're called in BDD. So we're going to save a model. So we're going to look at our snippet model. And so when we write a BDD spec, we start with a context. So the overall context for our spec is the object under test. So in this case, our snippet model. We then describe the condition, the context of the behavior that we're interested in, so in this case when it's saved. And we need to provide a setup function for all the examples that we're going to run on this. And the purpose of this is to essentially set up that context. So the first thing we need is a fake server. So this is the syntax for creating a Sinon fake server, very simple. And that actually running that one line of code will simply any AJAX request that you make will be caught by that fake server and allow you to inspect those requests. We then got some attributes which match the attributes of the snippet that we want to save. And then we're going to create an actual snippet model. And finally, save it using the attributes. So this is standard, these last two lines, standard backbone approach to creating and saving a model. And as we've used a fake server, we then have to tear that down again after each test, so that if there are, somewhere in our test suite, there are real AJAX requests, we need to make sure that that's restored. Finally, we can write an example. So we can test that it makes a request to the root. And we do that by running an expectation. So the expect method takes the property, the variable that you're interested in making assertion against, and then running an expectation method against it. In this case, we expect the first request URL to equal the root of the site. And we can write another example while we're here. Normally you would make that first example pass and then come back, but for the sake of speed, we can write another example that submits the correct, check that it submits the correct body. So in this case, we can parse our request body using JSON, and then inspect the title and content properties and expect them to equal our attribute properties that we set earlier. So with Buster, here's one I did earlier. So this allows you basically to connect any browser to Buster, and then you can register it as a slave, and Buster will show you the list of the slaves that you have running. You can see at the bottom here I've got an iPhone connected on there. And running the tests will produce this output. So we have, we're only showing a couple of browsers here, but Safari and Chrome. And we've got some errors being thrown here. And the error that we've got is a URL property or function must be specified. Now this error is coming from Backbone. So when you, if you try it and save a Backbone model that doesn't specify the URL that it's going to use for that save, then it will throw this error. So now we can fulfill our example. And in this case, the only thing we actually need to do is that. Now I chose this example on purpose because we've written a hell of a lot of test code, and we've written about 10 characters of additional code to get that first test to pass. And this illustrates where I think a lot of people get stuck with TDD and BDD, is that there seems to be a huge amount of upfront work involved in getting just to this point. Right? My point is that will happen. What will happen next is that as you generate more examples and as you generate more tests, your code will start to become easier to fulfill, and the examples will become easier to fulfill, and it starts to, it's like a snowball effect on your code. So when we run the test again, we have a nice green unit test runner. And if you remember, in the unit test cycle, we go around a few times. We write a few more specs, a few more examples, and you might end up with some nice code like this. So this provides the rest of the functionality that I was talking about. So we have our snippet model, and then we have our form view. What I'm not showing here is the rendering. But we have a submit event handler called create that creates the model and then saves it to the server. And then the specs that cover that might look something like this. So we've got quite a few specs there running in Buster. And finally, of course, all along the way, we've been running our acceptance tests every turn to check what the next piece of functionality we need to provide. We might end up with a Casper test that looks like that. So this is one acceptance test and a whole bunch of unit specs. And actually, that ratio, you'll have quite a large ratio of unit specs to acceptance tests, and that's how it should be. In Cucumber, it's kind of less exciting. I think there's a pull request, isn't there, Julien, for colors? Okay, so this, if I'd done this morning, this would have been green. I checked it, I think 2 days ago. It was, yeah, anyway. So now we've got a fully passing test suite, so we can celebrate in our own small, appropriate manner. I do this every day. This is my life, basically. It's great. That's fantastic. But we're not finished, of course, because we've forgotten the refactoring step. Now, I'm not going to go into refactoring because that's a whole different topic. But needless to say, I think refactoring is actually kind of one of the most under-discussed topics in JavaScript. So maybe I'll come back next year and talk about that. But for example, the point is there are two different refactoring possibilities here. So at the unit level, each time you run a unit test and get that passing, there are refactoring opportunities at the unit level to kind of make a particular unit more efficient, remove duplication and so on. But also, as I mentioned earlier, at the acceptance test level, you might decide that your implementation needs a bigger overhaul. And at that point, your acceptance test suite becomes like an insurance policy for refactoring and changing a lot more stuff in your application. So what's next? You might decide it's time for the next acceptance test. That would probably be okay. But you might also decide, well, wait a minute, what about exceptional circumstances? In our case, for example, we've got a form, so you might start looking at form validation. What happens if a user hits the submit button twice? And these are things that are discovered by exploratory testing. So and exploratory testing is also a very important part of this cycle. So whether you do it yourself or whether you have QAs in your team that would help you out with this stuff, the point is that exploratory testing, any bugs that you discover get fed back into the cycle. So you should be writing unit specs, unit tests for any bugs that you discover in the same way. So you write a failing test for the bug, and then you make that test pass, and hopefully that's your bug fixed. So I've only really scratched the surface of what's possible with this stuff. I'm going to tout my own website, tinfruit.com. On that, I've written a series of articles about how to test unit test backbone, which I hope you find useful. Christian Johansson, who's the author of BusterJS and Sinon, he's also written an entire book on unit testing JavaScript, which I recommend. And Adi Osmani has also written some stuff on testing backbone in his backbone book, which is still in development, I think. So we have in JavaScript, we're kind of quite far behind other communities, I would say, in terms of testing and the tools that we have available. But with the work with people like Julien, it's coming on quite a long way in the last year or so, I think. And I think there's a lot to be explored here, and I think we've got to discover our own way to do things that aren't exactly the same as, say, the Ruby community. But there's a lot to be explored and a lot of fun to be had with this stuff. I find testing fun. You might not, but that's fine. So I work for a company here in Edinburgh called FanDuel. We're currently hiring. Just a bit of a dirty tout there. So if you're interested in writing PHP or JavaScript, then come and talk to me or one of my erstwhile colleagues over there afterwards. Thank you very much. That's it. Yeah, I could have chosen an example like that as an illustration of the sort of thing where acceptance testing becomes tricky. And you could, by doing that stuff, you're kind of on the forefront. I have tried that kind of stuff before, and it is painful. And I think what you have to do in terms of the choice of which technology you're going to use, which framework you're going to use, you have to know that that's the kind of functionality that you're going to be testing up front, and then maybe write your hardest test first and see what you can do with it.
But do you know if any of the frameworks actually allow testing?
I would say probably anything that's using a browser, a real browser, is more likely to give you joy. The problem is Selenium has had problem driving that stuff right. So PhantomJS might provide that kind of functionality. PhantomJS. So for example, Casper JS uses PhantomJS. And PhantomJS is a WebKit implementation, so it's likely to be very close to a real browser. Sorry, I can't answer your question directly, but it's not easy. Yeah.
I've got a couple of questions. Buster, your browser testing was looking up a bunch of reactions running the browsers. If you wanted to run that on a CI server,
Yeah.
does Buster allow you to use something like Zombie or to have a headless sort of generic set of browser specs run as well?
Yeah, so the question was, with Buster's slave browsers, can you use that in a continuous integration environment with headless browsers? I believe so, yeah. I don't see. Buster's kind of built with continuous integration in mind from the beginning, so I haven't really tried to use it in a continuous integration environment yet, but certainly it's got outputs that are compatible with CI servers. And I guess you could actually script it in such a way that you could connect the slaves from the command line, possibly. I don't know, you might have to do some initial manual setup for that.
The other thing I was going to ask was that
Okay, yeah.
Just to follow up on the previous question, I think probably about 18 months ago that I managed to successfully test in-browser drag and drop using jQuery.
Right, okay.
But not drag. Drag and drop.
Drag and drop is
Yeah, we need drag, unfortunately. Thanks, though.
This is kind of more less a question, group discussion maybe, but I thought it was interesting because I've been looking at it from the other angle and thinking for unit testing, how can I not use browsers and just write JavaScript and just run it as quickly as I can in Node, and then when I'm thinking about acceptance testing, then run it in all the browsers. Whereas you're looking on its head and saying, do the unit testing in as many browsers as you can, and I can kind of see the point
Yeah.
of acceptance testing. If your JavaScript's all good, the acceptance test should work. It shouldn't suddenly find new issues. Is that how you're thinking about it? Or?
Yeah, I think it's interesting. It's a good point. The question was, what was the question? The question is, I guess the normal way of thinking about it is that you would run acceptance tests in real browser, and unit tests tend to be running in a headless environment more often for speed purposes more than anything. I think that's I think this is horses for courses again. It depends on what you're actually writing, what application you're trying to do. If you're building a library, for example, which is not really looking at DOM stuff, kind of more data manipulation stuff, then yeah, absolutely, speed is absolutely crucial there. If you're writing something that might have some cross-browser differentiation because of the DOM or the BOM or any other weirdnesses, particularly Android, then yeah, running in the browser as early as possible is probably what you could do. So.
I can see that your edge case testing is going to be that's where you're at.
Yeah, that's right. Yeah. You remembered.
so the cool feature I saw on Buster there was that you could run your node tests and your browser tests from one
Yes.
time rather than running them separately.
That's right, yeah.
Can you get it to run your acceptance tests as well?
I believe that they are in the process of developing compatibility with PhantomJS, so it might be the case soon that you can run your acceptance test from Buster as well. Yeah. Leo.
I'm working in a team. We're really testing pretty much everything.
You work for Sky, don't you?
Yes.
Yeah. I used to work there as well.
So, well, we're using JEP. well.
So the question is, can we test CSS as well, right?
Can we?
Yes, but don't do it. That's my answer. I've had many heated discussions with my the old QA that I used to work with at Sky about this, because she really wanted to do it as much as possible, and it's just a. I mean, every front-end developer will know this, but you know, testing pixel positions in this day and age, when we've got, you know, you were talking about differences cross-browser, intentional differences cross-browser as well. Like, you know, you can with Casper you can set browser viewport width and stuff like that. And you could possibly test a position of an element to test your responsive designs, maybe. But it's never going to be 100% accurate. You're going to have to write kind of ranges for things to appear within. So, and you're ending up, you're kind of building in non-deterministic tests by doing that. And all the worst non-deterministic tests that we had were all kind of based on visual stuff. So no, don't. Yes, but no. Yeah.
Thank you very much.
All right. Thank you very much.